Hello biology students, and welcome to the third unit in the cardiovascular unit. So in this video I want to start off by talking about blood pressure. So basically what blood pressure is a pressure that comes from when the heart's pumping blood through the arteries. That blood literally slams into the walls of the arteries and the blood vessels, creating a force, and that force is blood pressure. Okay? Blood pressure is very important. This pressure is what allows blood to get around the entire body. You can think if blood pressure was very low, eventually blood would slow down and stop moving and wouldn't make it throughout, wouldn't make it from your arteries to your arterioles to the capillaries and all the way through. There are some other forces in play as well, but blood pressure is one of the most important forces to keep blood moving through the body. Okay. So kind of similar, a similar concept that's related to blood pressure is the idea of pulse, okay? And so as the ventricles contract, so as the heart contracts and forces blood out of the heart, it's basically forced into the arteries faster than it can flow into the arterioles. Because arterioles are smaller, the blood can enter the arteries really fast, but it can't quite get into the arterioles as quickly because there is less room. So this stretches the walls of the elastic arteries, okay? It makes them expand, and that's when you feel your pulse, you are literally feeling your arteries expanding and contracting as blood slams against them. So that pulse is actually the rhythmic stretching of the arteries. Okay, so let's talk about blood pressure and pulse just a little bit more. So as the ventricles contract, this is going to increase pressure. And remember here we're talking about systolic pressure. Remember in the video 1 we mentioned that systole was the time of the cardiac cycle when the heart was contracting. Okay, so when the ventricles contract, we increase pressure, and that's systole, or systole. And then during diastole, when the heart's relaxing, the arteries snap back into place. They relax as well. Okay, so the pressure, so you end up having two different blood pressure numbers. You have the systolic pressure, that's the pressure when the heart is actively contracting, and you have the diastolic pressure, which is the pressure when the heart is relaxed. Okay. So a lot of things can affect blood pressure. If you have bigger or smaller arteries due to things like hormones, stress, if you're nervous, that can change the size of your blood vessels and thus change your blood pressure. Okay. So kind of interestingly, the blood pressure and velocity, which means speed, are highest in the aorta and the arteries, which makes sense. I mean, right when the blood comes out of your heart, you're going to have the highest pressure and the highest velocity, okay? Because you have so many arterioles, you can kind of imagine arterioles are smaller than arteries, but you have a lot more of them. So therefore, you have a bigger volume overall. That's going to slow the blood down. As the blood goes to a bigger area, it slows down. And capillaries, even though they're the thinnest blood vessels, because you have literally millions and millions of capillaries, that's a lot of different places the blood can go. So that means the blood slows down even more as it enters the capillaries. Okay, so it's the slowest in the capillaries, but veins have the lowest pressure, and that's because veins are furthest away from the heart, so they're going to have the lowest pressure. So if we look at some graphs of pressure and velocity, you can see the pressure. So the red is supposed to represent arteries, this purple is supposed to represent capillaries, and the blood is veins. You can see as you get further in from the heart, the pressure drops and drops and drops until it's almost zero in veins. Whereas velocity, or speed, it decreases as you have a bigger surface area, and it increases as the area gets smaller. Okay. So blood pressure, you might know, is usually measured in two numbers. So blood pressure, a normal blood pressure is 120/80, and it is measured using a blood pressure cuff. And basically the idea is that you take the cuff, and there's a little device on the cuff that can measure how much pressure the cuff is putting out. You put the cuff around your arm and you squeeze this little ball to add more and more and more pressure, and then when the pressure of the cuff equals the pressure of your blood coming out, flow will be stopped. Basically, you squeeze it up really high, and then you slowly relieve that pressure, and once the pressure is relieved to the point that it's equal to blood flow, that's when blood can first push out, and that's how you measure blood pressure. Okay. So next, I want to talk about what happens when your blood pressure is too high. So having high blood pressure is called hypertension. And this would basically be if your top number, your systolic pressure, if it was higher than 140, or if your diastolic pressure, your resting heart pressure, was higher than 90. Remember I said on the previous slide, a healthy number is 120 over 80, okay? And having high blood pressure is bad because it's making your heart work harder than it has to, which is not good for your heart. So high blood pressure or hypertension is dangerous because if your heart is working really, really hard, the coronary blood supply, or the blood that actually feeds the heart, can't supply this larger heart that's working really hard, and that makes the heart weaker. Okay, so this increase, this should be an up arrow, so the increase in blood pressure is basically going to cause the walls of your arteries to rupture or to break, which could give you more plaque formation as they try to heal, could aggravate arteriosclerosis, and this can lead to things like heart attack, heart disease, stroke, or kidney failure. Okay, so we're going to switch topics entirely now. That was on blood pressure. So now we're going to talk about patterns of circulation. So in other words, what's the path that your blood takes through your body? So you may have already figured out we have two main circulatory paths, or two subsystems, that our blood travels on. It travels on the pulmonary circuit, and remember pulmonary just means lungs, so to and from the lungs, and then the systemic circuit, and systemic means body, so to and from the rest of the body. So let's talk about the systemic circuit first. So the systemic circuit carries blood between the heart and the rest of the body. So this would be when the blood enters the left side of the heart from the pulmonary veins and then gets pumped out to the rest of the body through arteries, arterioles, and then capillaries. The blood cells use that oxygen, and then it goes venules and veins and back through the vena cava, back to the heart. So that's the systemic circuit. Okay. There are many pieces to the systemic circuit. It turns out, the blood has to go to all the cells in the body, so there are different routes it could take. It could take the coronary route, which means it could supply the heart itself with blood. It could take the hepatic route, which means it goes to like the liver cells and the small intestine and the pancreas. It could go the renal route, which means it would bring blood to the kidneys. But in all cases, it's going to leave the heart, bring blood to some cell types, and then return back to the vena cava. Okay. So you can see that here, the blood leaving the body, and you can see in this case, well, maybe these are the cells that give the liver its oxygen. Maybe this pathway is the way that we can bring blood to the pancreas, or maybe this is the one that brings blood to the kidneys. You can see in that, but they all will come back and join back together to go back to the heart eventually. Then the other circuit now is the pulmonary circuit, and this is when blood leaves the right side of the heart, goes out the pulmonary artery, goes to the pulmonary arterioles, to the capillaries in the lungs, picks up oxygen, drops off carbon dioxide, then comes back via the pulmonary veins. So that's in the other secondary circuit here. Okay, so we look at the whole pathway now. You can kind of think we start in the vena cava, the inferior and superior vena cava, go into the right side of the heart. Then we're going to go to the pulmonary circuit, to go to the lungs and back, either to the right lung or to the left lung. Then from there, we're going to go into the left side of the heart and now do the systemic circuit. So we can either go and do the top half of the body, or we can do the bottom half of the body, but in either case, we're then going to return back to the heart afterwards. Okay. So finally, one last thing I want to mention, that in the pulmonary circuit, when blood does go to the lungs, that's where some gas exchange is going to happen. So the part of the lung where gas exchange occurs is called the alveoli, and we'll see more about that next unit. But alveoli are they're special cells because they're only one cell thick, so it's very easy for oxygen to enter these cells from the outside and carbon dioxide to leave. And alveoli, they're surrounded by blood capillaries, and the oxygen and carbon dioxide just diffuses in and out of the capillaries into these cells to allow for gas exchange. So that's it for video 3, and I'll see you in video 4.